Our first speaker, I'm going to bring him in. Here we go, at stage. This is Ahmed. I met him at KCD New York last April. No, it was May. May. I'm like, confusing. And if you're in the New York area, you should definitely look out for this KCD. It was so well run, such great speakers. So make sure you watch out for that. And if you're in the New York area, make sure you reach out and maybe you can help organize it and run it. So Ahmed is here from the New York Times. He's here to kick off the day, set up us all on this platform engineering journey that we are on. So I will add your slides in, and then I will kick ourselves out.
Awesome. Thank you, Danielle, and super excited to be at Cube Crash. It's my first time, and hopefully it's not the last. So super excited to be here. And I'm here today to talk about like our journey at the New York Times for how are we using platform engineering. So let's start by like just quickly introduce myself. My name is Ahmed Bebars. I'm a principal engineer at the New York Times, and my focus is building reliable platforms and ensures that everything from an infrastructure perspective is well managed. I lead runtime operations and build scalable infrastructure for our products. And definitely, I'm a dad. I love Go. And when everything is settled and when my code is compiled, and I love to go explore under the sea. So scuba diving is one of my passions. Besides spending time with my family. So if you have any recommendation for dive sites that you heard about or you did, please let me know in the chat or send me on social media. So let's dive into platform engineering and see how we did this journey at the New York Times. So I sliced this talk into like 3 sections. Like first, why we are going to talk about platform engineering, why platform engineering, there are other mechanisms that we've been using for decades here, and then how we're going to build or how to build an internal developer platform, and then we'll talk about our platform journey at the New York Times. So let's start by foundational understanding of what platform engineering really is. So by definition, platform engineering is a discipline focused on modeling and delivering consistent experience that optimize the processes of development, deployment, monitoring, and all of that other things that engineering teams requires. But the most important thing, it's that uses self-service approach. So allowing team to access and manage and utilize all of the tools and service when they need with minimal friction. And the point here is like about the friction. It just like have to be the same experience. So we'll break the definition a bit into like smaller pieces, and I highlighted like few key elements that I would like to spend some time on. That consistent experience here refers to like creating and unified the standard environment. So like when engineers, developers, teams try to create like a service or an application, they usually met with the same experience every time. So it reduces the room for errors, fostering like high productivity and product quality. Self-service approach is about making sure that we empower the engineering team, giving them the autonomy to access the resource, manage the workflows as they see fit, resolve issues independently without having to go to other teams or platforms team to work with them, which by default, this should accelerate the delivery time. And lastly, provide extensible tooling means that the platform are designed to be flexible and adaptable. And this is important in, we're going to talk about this later, but like the tooling and all of the tools usually evolve over the time. So you just want to make sure that whatever you are building today is adaptable for tomorrow. Like we can plug and play tools and all of the kind of good things about like decoupling the platform into smaller pieces. So in essence, platform engineering is about crafting an adaptable and efficient environment, empower developers to create their application seamlessly. So we know what platform engineering is, but why we need it, and when we already have ops teams, we have DevOps, we have cloud engineers, and that's like where like why another things? Why a new term? Why a new concept? And the answer is simple. As technology gets complex and evolve and operations gets bigger, we need something to bring everything together. So our existing teams are already doing great, but platform engineering combine all of these efforts, making things smoother and more efficient for everyone. It's just like we are taking all of the good stuff from all of the things that we learned over the years and just mixing them to have like a super team which focusing on the experience, focusing on the delivery, ensuring that we everything run like a well-oiled machine. And we're gonna get deeper into like why platform engineering is so crucial and how it stands out in a world filled with various tech roles. So let's start by how we originally had to set up. Like back in the day, traditionally, software development would start off like dev team, ops team. That's how you see it. Like you have your dev team, which usually understand the application, understand like the business requirement, and then you have your ops team, which is usually like ensure reliability and SLOs and make sure. The problem here is the disconnect between dev and ops. Usually, this results in a delay and miscommunication and lack of unified vision and understanding of like how we deliver software because their metrics are different. Like the developer team is focused on the business change, the features that they want to deliver. They want to deliver more things, they want to deliver more faster. They want to make sure it's working, but like the goal at the end of the day is the feature delivery. The ops team is more focused on reliability, making sure the system is working well and like nothing is breaking. So like when you have this lack of alignment in some time and the silos between how you make like the software works and how it actually works, it creates like some friction around this. And the evolving landscape around this already like a shift into how we get there. So that evolved into DevOps, where like we had our dev and ops teams, like we combine them together, we get the DevOps come in, and it's all about getting development and operation to play nice. So it already did a great job, like breaking down walls and bringing a nice culture between everyone, aiming to continuous improvement. Like, and a few things like that we got from here is just like we get an enhanced collaboration because we promote a culture between communication between development and operation. We have a shared responsibility between teams. We also increase the deployment frequency because we started to integrate things like CI and CD into the process. We have faster time to market because think about it, we had like communication silos between dev and ops. Now we bring them together so they understand the full cycle of the application. Get more improved quality and reliability, get more greater efficiency because we are now automating tasks and doing like things in a very efficient way. And at the end of the day, we get like the customer satisfaction and the scaling effort that we are looking for. So that transition represent a holistic transformation, and that was a game changer in meeting the demands. But still, that wasn't like enough to get us to where we want to be. And like, I would love to borrow this content from Daniel Bryant, which he presented this at PlatformCon 2002, 2022. Which he was talking about like how the technology was evolving and like races ahead. So when you think about like what we as an engineer, as a DevOps, as a cloud engineer needed to know in 2000, it's completely different from 22 or 2020 or 2025, like wherever which year we're talking about. That like the days that back there, like there was limited to like smaller operation. You have like is a get operation. You have your code. You know where you're deploying. Usually, like it might be on premise. Then like evolves enough 5 years after, more IDEs, more things that's cognitive load keep overloading everyone. So the problem comes into like now you have to know a lot. Like you have to understand like the whole ecosystem to understand like to go for what's next, how to get like an evolution on the process. And that has a cost because the cost of understanding like how to put all of these pieces together makes it harder for engineering teams because that's where friction starts to come in. And I would love to walk you through an exercise that like I'm using most of the time in the presentation when it comes about innovation. So I'm assuming that like I give you like these color palettes, and the ask here is like each one of you would imagine like how you mix them together. So like the concept here is like this is what tools we give to teams and ask them like how do you put them together. And what you're gonna see here is like Sure, the tools are the same, but how teams usually put them together is a little bit different. So you see, like each team fits them as the senior, like workflow, understanding of like how things look for them, like how they deliver an app, and that's great. That makes this team like well oiled, like works. Problem comes into like when team starts to do cross communication, things are not the same. They spend time tailoring these tools to work for like the experience that they would like. So the goal here is to help bring a unified experience across like the entire ecosystem. And the next slide is really like I can't get enough of like to fit all of the tools here, but this is the ecosystem from the CNCF landscape. And believe it or not, there are like a lot of missing tools, and this is evolving on a like every week, every month. And you can see like CNCF already, if you're not familiar with the terms, that stands for like Cloud Native Computing Foundation, and it has a lot of different technologies and a lot of things comes every day. That richness makes it harder for people to digest all of that. So the one problem here is that like you imagine like you would have a team that understand all of these tools, see where they fit, and works with developers to shift their like tooling and product to make it like to make them give them tooling to deliver uh their product. And I will talk more about like so many options and so many choices that we have to work through. But let's start by one thing here. So let's get more to an idea of like having everyone in sync, and we're using different tools. So earlier we talked about like if I give teams different tools, you probably like have different setups. And when you picture like something like, hey, we have all of these tools in our organization and into an enterprise. So how you mix them together? You're gonna find out that the teams picks whatever works for them. Like they sure every tool has its perks and every team has their favorites, but when they don't match up things get a bit messy and confusing, and it's tough to keep projects in track because now you have a challenge of understanding, have a challenge of like nuances comes into like everything. And it's the quality, it's not going to degrade, but like the quality is going to be different from a project to project. So there's no way that we can unify the experience across the enterprise. So having different tools is good. It's more flexible, but it's not the best way of balancing everything together in a well shared approach across the organization. So how can we bring everything together? So when we think about like, let me just focus in one piece. Like if I wanna specifically pick some of the tools, let's say I'll pick AWS, I'll pick Kubernetes, I will pick Argo to build some abstraction. And when you get all of these together, like you just build a very abstracted layer that makes it easier for people to understand. It makes it easier for the workflow to be like streamlined across all of your engineering team. So you kind of provide like guide guide rail for like every for all of your teams. It doesn't necessarily restrict them from doing things, but it's at least gives them the golden path for like how they go for it. So take for instance like AWS, it's comprehensive cloud service platform, but like we can swap it with another platform if we need to. But like the platform itself abstracting this piece, it just makes it easier for engineers to start their work quickly. Kubernetes is the same. Some teams using it, some teams are not, but like just simplifies the container management. Argo CD, like your whatever choice of CI or CD, and for sure the source. So by doing that, we are not just providing an easy to navigate, but we're also ensuring that despite the diversity of tool and processes, we have like all of the tools are aligned together. So you don't engineers or teams don't have to spend too much time on figuring out how to make things work. And that's where like we go further and like do like centralized operations and paving the path for like develop tools in a different way. So that makes centralizations much easier, makes a good unified approach across all of the teams. So the idea of paved path is essentially creating clear, well-defined guidelines to developing these tools and all of these methods and processes. So let's think about it. We will look at and say, okay, so now we have platform teams. We used to have DevOps teams, and like, isn't this is another silo, like how this is different from like the original approach. And like creating centralized operation is not about building walls, it's more about like laying the foundation. So like the teams still can still use establishing baselines and use these idbs to create their own efficient workflows, but they don't have to invest too much time in the breaking ground things that they built for the platform. So all of these connections have been built, and we already having a unified based and clear pathways on how the teams can start this. So from that perspective, like we trying to create bridges between everything, just like making sure that the DevOps teams are, or the teams in general from an engineering perspective, are empowered to do their own things, and have an understanding and a good way of starting on things. And let me speed it up by talking about like how we can how to build an internal developer platform. So focusing the developer journey, like there are some areas that I would love to highlight that they usually come in between different teams. And these are the create, the code, the build. These are the same over and over, but like the difference is the idea and the plan and the design, and that's differentiate between one team to another. And in this way, when you try to think about like how to create an internet developer platform, there are a few pieces that we have to unify, make it easier for everyone to understand across the organization. And when we talk about this, there's like internet developer platform. There are like a few pillars I would love to just quickly highlight. Standardization, just make sure that everything's running on a standard. Efficiency, you have like a lot of good measures to like understand like what's working efficiently and what's not. Integrations, provide integrations between different tools and different, you have a cohesive platform now between like how to promote collaboration between different development process between different team. Scaling, and not necessarily like how to scale like the runtime or your clusters, or but I'm saying like scaling to the organization need, how to add more and like run on the project on scales, and definitely the visibility element. So one good question that we always ask anytime is like, this is a big question, like should we buy it or should we build it? There's no one size fits all to this. It's depend on the organization, and it really like what I advise you from my experience is just like start with an MVP and then like put your requirement and think about like should that's something that we should build internally. That might be an investment if you think like long term, but like other organization would prefer to buy it earlier. So it really depends on like your use cases. But the one thing that we have to focus about is like either you decide to build or buy. You want to ensure that like when you build your workflows, you have like a data model across where your platform look like. So you want to have like this distinguish between what's a workload, what's a service, like how they correlate to each other. So even if you decide one day to build as an MVP and then to buy, like this data model will grow with you. So like that is a unique understanding across your journey. And transitioning to like the actual workflows on how we like thought about this at the New York Times, when like we started a workflow, like okay, how to create an app, how to like get it to engineers to work through it, what we give them on like the build and deploy and test, how they run it, how they route it, and of course the observability. So these are the workflows that we start think about on how to deliver. And quickly I'm gonna go over like each workflow, like but like just quickly, just to ensure that like I go over the example at the end. Talking about blueprints, shared libraries, artifact, you want to invest in everything centralized at this point. So you want to make sure that like you have less overhead between different teams. We talk about build, like you just want to make sure that all of your CI, CD testing environments are similar to each other. Environment and cloud runtime and cloud resources. That's where like application operation, like defaults, and teams have the power to tweak different things. Talking about the routing, which is like that's where like majority of how the traffic comes to your application. So that's where we're talking about ingress, we're talking about CDN offering, all of the kind of service to service communications that happens between applications. And then the last, which is the monitoring, and that's reliability and cost management. So holistic view is that's usually where like you have your internal developer platform, and like I split into different areas where like what the developer have access to, what the platform has access to, like what does the infrastructure space look like. And you can see like there's a different areas where like developer would get their IDEs, they have their application definition, UI, API, CLI, where like as a platform team you would have like your CI and CD resources and all of the kind of tooling that we look for. So again, just going over the three pillars that I highlighted earlier in the definition, developer experience is very important, has to be consistent. Talking about like self-service, just want to make sure that it's not platform doesn't mean it's a Jira ticket or it's not a ticket for someone to go do the work. So developers should be able to like provision, deprovision, startup, all of the things that they can be able to do. And extensible tooling means like adaptability, how to swap things. And quickly we'll run over our platform journey at the New York Times. So when we started thinking about this a few years ago, it was like, sure, let's provide tooling and infrastructure to everyone, and that works well. Teams started to like use these tools, but then like we looked at it and we have seen like different experiences, different workflows, and then like we started to organize like centralized cloud orchestration, and that's where like things became better. We like abstracted a few pieces about the cloud runtime, things like that, and then we started to think about centralized developer platform. And from there, like we are going into different iterations into how we look at our internal developer platform. But to give you highlight over like how it looks like right now, so that's where like you can see an actual offering for our internal developer platform at the New York Times. Definitely you see like the user or the developer goes through like a template engine, goes through like getting to GitHub, their CI, their Argo CD deployed on Kubernetes, what they get from secrets, all of that backstage for like their catalogs, they get observability and monitoring as well. And this is like how you would experience an internal developer platform. But let's pick on two examples that I want to just show you quickly. So the first example is like how I create an account. Like I don't have a cloud account as a team. So how I do that? You do that by like going to Backstage. That's your dev portal that like you would need to have something around this into the organization. So you request an account. There's an orchestration process happen behind the scene. Something gets spun up and a process get kicked. Account gets created. By default, when you create an account, because we already seamlessly integrated all of our pillars and all of our workflows into the process, when you create an account, it's just like it's not just a cloud account, but also it's onboarded to the runtime ecosystem. So what I mean by that, it's automatically onboarded as a tenant to like our EKS clusters, which is our runtime. So by default, like once account is created, developers have access to deploy applications automatically. That takes like a few minutes to get there. So that's like a benefit of like, okay, now they can just, if they have containers, they can quickly run it. And that's one great benefit of it, because like developers don't have to think too much about like where should I create it, how I can get the setup. All of these tools are offered to them. The other one is the application creation, and it's very similar process, and that's where consistent experience comes handy. It's like they still go to Backstage, request a new applications gets created, they get all of the shared libraries, they get all of the definition, all of the cloud resources that you need, and from there the application is already deployed. So they have all of the pipelines, they have the image, they have all of their monitoring spun up there, so they are ready to start thinking about their application and adding their logic and business ideas. And this is like just a quick journey over what we have. But like just like a few takeaways to learn about this user documentation, it's crucial in any platform. Like we are engineers, like we complain too much when we use a product or something that doesn't have enough documentation. So keep sure that you have documentation handy. Partnership is a great element to work with teams when you are building applications and when you are building
All right, everyone.
I think Ahmed might have frozen for a minute.
We'll give him a minute.
Okay, I got disconnected. Sorry.
Oh, there you
Oh,
are.
okay.
We
My
came
VPN
back
played a
in.
trick on me. Uh, and that partnership, as I was saying, like it's crucial to have partnership with your teams. Uh, Platform as a product. Don't think about a platform as a project. Think about as a product long term. It will consistently like continue with you. So it's different iterations. So you don't have to deliver everything day one. And then customer feedback. Customer feedback is super important. That like this is that your North Star metric where like you're gonna have to think about like how to iterate and listen to your customers and your teams, and they are internal. So like you would get like honest feedback most of the times, and if you work with your teams, like they would be happy, you would be happy, everything will get delivered on point. And that's quickly in 30 minutes our journey at the New York Times for how we build a internal developer platform.
That's amazing. Ahmed, there's a couple of questions for you. If you have a minute to hang out
Yeah.
and answer a few. I think there's a general question that we might table. It's how does AI affect everything? That's going to be a theme throughout the day. If you have time at the end, you can answer that. But there's some specific questions for you. How many developers use your infrastructure tooling?
We have like a lot of teams. I don't know if I can say like exactly how many developers, but we have like hundreds that use platform as currently.
And then we have another question. I'm going to put it up here. Do you provide templates for applications for multi-region deployments, or developers do that on their own for different regions?
We actually do. So like the platform by default, I didn't go into like specific details, but the platform by default is multi-region, has this built in. When we like give you the option, we give you the option to choose. So it's really dependent on like what you want to do, active, passive, or just like a single region. But by default, we deploy to a multi-region. Multi-easy is where you take like all of the availability and you just turn it on, turn it off based on your needs for your application. So
awesome. And then we have another question. How are you encouraging the adoption?
That's a great question. And first of all, it has to be a partnership. So like the teams that are working to adopt the platforms, they have to see the value. And the one thing that like we have seen that works well is shows the value of like the overhead of managing any infrastructure is a lot. Like a team has to understand like what they're running, how they run it, all of the pieces. So one thing that I could tell you is like once you're onboarded to a platform, and let's think about take it to a different route. Let's not talk about platform. Let's talk about like if you go to try to get a VM on the cloud. Like back in the day when you try to do this in a data center, you have to go purchase the hardware, you have to install the operating system, you have to maintain it, you have to patch it, you have to do all of that. Now when you try to get a VM, just have a click and get a VM ready. So think about the same. Fast, like if I'm a developer and want to run my stuff on Kubernetes, I have to get a Kubernetes working, have to do my multi-region, have to do all of the stuff to work. So showing the value of what teams can get out of the box without have to think about all of this overhead and all of these features you keep adding, because you focus on the product and then the teams focus on their business logic. That's where like we show the value on, and mainly it's just like listening to the customer. So what they really need, what we need solve for. So the partnership really helps and the customer feedbacks really helps. But what we hear from teams is that like we remove a lot of overhead, we make it a consistent experience. And what you're going to find out over some time, when all of your engineers know how to navigate the platform, you will find like champions. Like as you say, you don't have to be the only single person who knows how the platform works, but you're going to find other teams like start to chime in. Oh, like if you want to do this, you can do it this way. We started to do this template, and people start to customize pieces all over.
Awesome. So I'll do one more question, and then hopefully you can stay around and answer a few more that are coming through. We have do you see any resistance from DevOps teams?
Give or take, yes. Depends on the situation. And like this is really, it's not a resistance, but like if you already created your own workflows, it's just like a change is a different thing. You just have to learn something new. Like that's where like you have to partner. That's partnership here is critical, because what you show them is like we are not taking anything away. We just like giving them a lot of these tools. In some areas, we work necessarily with DevOps engineers who understand like many layers in the platforms. We are not trying to how to say this, but we are not trying to close, like it's not like a closed source. It's more of like we just like provide the service, gives you all of the tooling, you still can customize and build on top of it. So
Mhm.
in some cases we do, but usually they go over time because like teams find out that like, okay, you do it this way. But it's one thing that we learned is that it's very important to provide escape hatches. It's not to make everything like just like this way and the only way. Just in some certain scenarios you want to do that to avoid like friction, but like in most scenarios escape hatches are useful so people can build on top of it and iterate with you, and also listening to them would be super helpful.
Awesome. Well, if you could hang around, there's a few more questions.
Sure.
It would be great to have you answer them. I do love, the whole your comment around a well-oiled machine, and Daniel Bryant borrowing his cognitive load. He's actually a Cube Crash alum. He's presented here. So I do think that is a really interesting graph to show, like, here's all the things you used to have to think about, but here's all the things to think about now. So really appreciate you being here. Again, if you are in the New York area, KCD New York, watch out for that. Ahmed will be planning that, and it was really good last year. So thank you.